let's start by looking at the landscape of disruptions and why resilience is so important and more critical than ever. So supply chains continues to face mounting pressure from range of disruptions, port congestions, container overcapacity, geopolitical instability, and regulatory shifts around emissions and sustainability. In the light of these developments, what are the most critical challenges that supply chain leaders are navigating today? And what are the most critical fires that you need to put out? And how these challenges reshape the way we think about resilience, agility, and long-term strategy? Alessandro, maybe we'll start with you. What are the observations based on the experience that you have with your customers?
Sure. Thanks, Magdalena. Thanks for the introduction. Regarding the poll, I think there might be a bit of a selection bias given that the sample is the participants to this webinar. So of course, both we here at Siemens Digital Logistics as well as Portcast are technology providers. And rarely is a technology developed in a vacuum and then sent in search of a problem to solve. Right? But the complexity and uncertainty facing supply chains today are increasingly becoming each other's multiplying factor. And this shapes how tech that is domain agnostic is put to use and validated in the field. So the factors and trends you were also mentioning whose interplays drives the need to establish resilience, right, include growing product complexity, right, requiring more sophisticated manufacturing capabilities and often smaller lot sizes with more variance and much shorter lead times. Global supply and component shortages, right, potentially creating delays and increasing costs for components and materials. An increasing complex supplier and partner ecosystem, right? So multiple partners and suppliers involved, coordinating actions and activities, and ensuring effective communication can be a source of misalignment, and itself a multiplier of risk, delays, and costs. And lastly, an increased focus on sustainability and the need to control costs. So businesses are increasingly expected to be environmentally responsible, reduce their carbon footprint to contribute to sustainability goals, while at the same time properly managing costs, again, to remain competitive. So why is resilience essential, yet hard to achieve? Right. So volatility, frequent disruptions from pandemics, geopolitical events, extreme weather, including over-reliance on a few suppliers in a few regions. Siloed systems, data trapped in functional silos are simply unavailable. Limited agility, so slow reactive decisions due to disconnected planning and execution, software tools and processes that can't be designed or adapted quickly to handle novel changes, and lack of visibility. So only 21% of leaders report end-to-end visibility from a recent McKinsey report. And 2023 is maybe even a happy time if we look at where we are now for this statement. So when it comes to AI use cases, I'll let Nidhi then take on.
Thank you, Alessandro. So we've seen the big picture. What I wanted to focus on is how disruptions impact your supply chains, shippers' supply chains. And I wanted to share some of the data that we've seen from Portcast by working with various shippers. First of all, most companies still rely on carrier or forwarder to update what's happening to the shipment. And that's through an email or through their websites. And it's not just the operations team that is chasing a shipment. At least 5 to 7 different teams, from factory to customs to finance, are basically chasing the same shipment. So we're really talking about a people problem which can be solved with data and AI. Next, let's talk about planning delivery times. We know that every company has to plan an entire delivery SLA from the factory till the final delivery. And if there's cargo on in the transit in ocean, we're looking at average transit times that come from historical data. Here is the data for average transit times, the planned transit times from Asia to North America over the last 1 year. So we can see that the average transit time stayed constant around 31 days. But the real story isn't the average. It's the volatility. Here's to deep dive. So let's look at January, which is highlighted here, January 2025. The average planned transit time was about 32 days, which is the blue bar. But there were delays on an average of about 8 days, which means that if a shipper planned their transit time to be 32 days, they were actually seeing about 40 days of transit time. That was a reliability of about 33% of their shipments. which means that a planner which used the sort of 32 days transit time was constantly having to adjust their transport plan, their inventory plan last minute. If you look at August in the same trade, what we see here is that the average planned transit time was 29 days and it was much more reliable to about 56 days. So not only were the shipments faster, but they were far more reliable, which is exactly what enables leaner inventory and better customer experience, better customer service. Let's look at the same numbers from Asia to Northwest Europe. So the planned transit times over the last 1 year, if you look at month on month, they stayed between 44 to 46 days. But again, let's look at the variability. Let's look at the delays. So in the winter months from December to Feb, it was especially tough with delays of about a week, so 7 or 8 days. And reliability in the green line bar that you see here was about 23 to 31%. And if you look at the last 3 months, the delays have become a little narrow, so about 4 days, and the reliability has gone up to about 45 to 55%. Still, if you think about this chart and the previous chart, on an average, even in the best months, the overall carrier reliability was around 50-55%. But the main thing is that we have a problem in planning to the planned averages or planned transit times. We can't depend on these planned transit times. We have to make them more dynamic. Otherwise, we're constantly having to firefight to adjust the transport plan at the downstream or the inventory stockouts, etc. Those situations. Now, when we think about transit times, we think that the entire sailing time, the ship's sailing time changes. And that's not really always the reason why transit times change. Here's what our data shows over the last year. 1 in 11 shipments were delayed because they were rolled over to another vessel during the transit. 1 in 4 shipments were delayed because the vessel departed late from the port compared to the original plan. And 1 in 4 shipments were impacted because of the schedule changes, so a port being skipped in the schedule, etc. So operationally, it is important to know the hidden reasons behind the delays. It's not just that the sailing time is changing all the time. These reasons that you see here on this slide are really carrier initiated or carrier caused changes or delays. But it's not just that the carrier is the only party that's responsible for delays. There can be completely unforeseen risks like congestion or typhoon. All of those obviously impact shipments. There are also geopolitical issues, there are strikes, there are accidents. All of that basically means that we're constantly looking at all this news and information that's coming in as a planner, as an operator, and trying to understand if our shipments are basically impacted. Rather than receiving so many of these alerts, what we really need to do is remove the noise and set up alerts that actually matter. And finally, the financial impact. On an average, 8 to 12% of the total freight spend still hides in detention, demurrage, and accessorial charges. Any delays could mean that we are not getting paid on time because the arrival may be linked to the payment schedules, and that impacts cash flow, working capital, revenue collection. And other problems that we're seeing are, let's say, split booking. So imagine 1 out of 10 containers did not reach the customer because it's still staying at the port, and the other 9 have arrived at the customer's location. This does not amount to on time in full because 1 container is still sitting at the port. And it means that the customer experience is impacted, it's directly hit, but also it could lead to penalties. And still, the overall shipment ETA still kind of looks fine. So here are some real life examples or data sets, Alessandro, that we can see on how disruptions impact shippers' supply chains.
So, as Alessandro mentioned, one of the biggest challenges is the lack of visibility. And we saw that only 21% of the leaders actually have visibility. And Nidhi, thank you for guiding us and taking us behind the scenes. So thank you for showing us delays and what is not visible to the customers. So it's obvious that this data is available and it can actually help supply chain leaders navigate through disruptions. I mean, we see that disruptions mean also increased costs. So it's not only the unhappy customers that are not getting their products, it's also revenue loss and then higher costs. So in such turbulent times, how can supply chain leaders build resiliency? And do you believe that artificial intelligence can solve all of our problems? Is it a hype or is it something that can actually help? Because I mean, you show a lot of data points. It's showing what happened in the past, but leveraging AI technology can actually give us a glimpse in the future. So, Nidhi, can you comment on that? Or Alessandro, both of you?
Sure. Well, it is what I'll be getting into, right? So I think we can look into a few numbers and a few solutions. Just to very quickly address the point you raised, the workflows and processes and the problems are the same, right? What AI gives, if it's implemented the way it can be measured, right? And this is one of the core aspects because we're talking about software, we're talking about tools that have to fall within the same frameworks of software development and operational excellence. Then yes, but within a system, control tower, where the flexibility can actually be leveraged. So to get into it, right? So there are also, of course, market expectations when it comes to AI tools and use cases in supply chain and logistics. So there's expectations on impact, but I think from a practitioner's perspective, there are operational expectations that can be put to the test, and that's whether these are, like Nidhi was saying too, right? So significantly faster disruption response, reduction in inventory costs, improvement in service levels, and generally addressing the problems of responsiveness, flexibility, and visibility in what are complex systems. And I think we have another poll now.
Nidhi, would you like to comment on the AI technology before we ask our customers and participants how they...
Yeah, actually, I think the technology has grown exponentially. I think we're in an age where what Gen AI can do, I mean, we're seeing it in all the tools that each of us are using. It is incredible. And it is really powerful at this stage to act as a tool, as an enabler for logistics operators. The other thing that AI needs is good data. The foundation needs to be really right. And then both of them coming together, AI and data has the power to really make us take better decisions. It's really not about removing the human, but it's about enabling the human operator. So I think we're actually living in a great time where we can leverage these tools to make efficiency and make supply chains really touchless.
I really like what you said, that it's not about removing the human, it's about enabling the human with high quality data to make better decisions, because we are experiencing unprecedented challenges, and I think we need all kind of supports to navigate through this. So a question to our audience, are you using already artificial intelligence or Gen AI? So how do you make use of this technology? Are you actively deploying it in your supply chain, or still evaluating various options? Seeing the first results, I mean, I guess that's the reason why most of you joined this webinar. I think AI is still quite a new technology, and that's why many people are evaluating and trying to answer the question, how can it actually help me? So we see 93% still evaluating. Okay, it's changed now to 88, but it seems that the majority of the participants in our webinar are still searching for answers. Okay, how can AI actually help me navigate through disruptions? And this leads me to the next question to my speakers. So will you elaborate on how a joint solution of supply chain management and leveraging the power of AI can actually look like? Can you describe it for our audience and talk a little bit about how the joint solution could look like?
Sure. So let's get into it. So generally, right, what we're looking, so what Nidhi was also showing, right, in terms of disruption, unknowns, the levels of certainty one can have in terms of a process behaving as it should or how it's been designed, and especially how it's been implemented in a software tool, is really the starting point. So generally, what one would want to start, what would want to manage by exception, which is generally meant to say you have your standard process and you put more attention, or as an end goal, right, all and only your attention and that which deviates from the standard. And the problem arises when there is no standard, right? Or every standard process can potentially deviate at some step with information or information gaps that are peculiar to that point of the process or that specific event or time frame in that part of the year, in that part of the world. And at Siemens Digital Logistics, we build software, so namely our AX4 control tower, to handle such workflows, their deviations and their forks, the exchange of information and the definition of communication and task responsibilities in a customizable and extensible way. So there are multiple ways in which AI-enhanced workflows can be implemented in AX4. So you can't improve what you don't measure, right? So defining, capturing, and monitoring metrics still is the starting point. And metrics depend on data, as Nidhi was saying, right? So access to the right data at the right time and how that knowledge is used, by whom or by what, is the foundation to designing flexible workflows to handle supply chain processes. So this view is, let's say, a typical high-level overview of the type of flows that we have and the type of data-connected systems. And without taking too much of a tangent, right, much can be said about end-to-end, and it doesn't just end here, of course. It's a system of systems. But every data point and every exchange here is a potential entry point for AI use cases. And right, so far, when we're discussing, let's say, process modeling, which partially this is, and flexibility, we're talking operations, right? So I was always saying, like, each process is itself made up of multiple exchanges and data points that are themselves, in turn, the product of upstream processes and can become the triggers for downstream ones. So we can consider this type of orchestration, process of processes, right? And at Siemens, we have a portfolio of interconnected products that go far beyond what is shown here. They consume and feed data points in real time from suppliers to your own factory planning and scheduling tools. So goods in transit, right, can be used in production planning in real time or also with simulations. So on the solution, right, Corey here, when it comes to systems, right, and platforms that feed data into control towers, our partner Portcast here is a great example of how quality real-time visibility data and the context of that data can be put to use in whichever way it needs to be used and put in front of whichever party or connected system is tasked with acting on it. So having the what is happening, right, together with the why it's happening for both humans and machine to make use of is one of the key enablers in making exception handling part of core workflows and AI ready effectively. And that is next to, of course, what Portcast already does with AI and with machine learning to be able to construct and provide such data. And I think we come to the next point here.
So if I understand correctly, the solution is about not only gaining visibility, but also sharing it, because you mentioned that the control tower actually uses different data sources, one of which is the Portcast AI-enabled ETAs, but it's also shared with all the stakeholders. I think it's important to make our audience aware of this fact that it's not only about gaining visibility, it's about sharing it with all the stakeholders, because you need to inform your customers along the supply chain, your suppliers, about any possible changes. As much as I like the theory, I think our customers and audience today are interested in, okay, how does it look in the practice? So how do we turn the challenge into a chance? So can you share with us the experience of the mutual customer using the integrated solution? I think it will be interesting for the audience to learn more about it.
Sure. So as an example, right, so one of our existing customers, US automotive OEM, so was already making use of our control tower and had defined workflows and processes which had already been automated and reduced manual workloads, but was still facing data gaps, right, due to missing carrier data, was not getting correct or complete data at the right time, and had to still rely on interfaces that had been designed for manual processes. So these are some screens from the original run of the solution. So by capturing and providing data and context, the actual flow design could be adapted and designed around additional actionable data points rather than around gaps. So missing carrier updates, transshipment delays, end-to-end shipment flows, including mode changes. These were missing and were then determining effectively completely manually defined workflows in an otherwise automated control tower that goes beyond ocean visibility as well.
Yeah, Alessandro, you said that already, but maybe just to add more insight to the screenshots that the audience sees here. On the top left, what you see is an example of a shipment where the carrier did not update that the vessel had actually departed. And instead of waiting for the carrier to provide this, and various workflows depend on the departure timeline, solutions like Portcast are able to basically fill the gaps of such carrier information from other data sources. And that's what makes the completeness of the data possible. That's one example. Another one on the right-hand side, what you see, that screenshot there, is a shipment that was idle at the transshipment. Now, transshipment is one part in the entire shipping journey where actionability can actually take place, because if we know that the shipment is idle at the transshipment, imagine it's a perishable, or for this automotive parts manufacturer, it is highly important to receive this part on time in order to meet their assembly production timelines. So then they can actually enable, talk to the carrier, try and figure out how can they avoid further delays if they know that the shipment is idle at the transshipment already or likely to be idle. And what's the next sailing that's possible? Similarly, if I just move on, like another couple of interesting insights or value add that the customer achieved was, one, their shipments were impacted by the typhoon Rogasa, which recently impacted South China Sea. And essentially removing all the other noise, getting them information on exactly which shipments are impacted because of this typhoon and what does it mean to be impacted, that's what creates actionability. On the right side, it's also about raising that there's a detention demurrage likely already being incurred. And if they don't pick up that shipment, then there's going to be an further escalation of those costs. So these are cases where the customer starts to see real value from the visibility information. And finally, it's not just from a port to a port location. It's really also about capturing the land leg milestones as much as possible, pre-POD or post-POD, and that starts to then enable full journey visibility. Alessandro, back to you.
Thanks, Nidhi, for walking us through the integrated implementation. Right, so using the Siemens Control Tower, the customer achieves measurable improvements in end-to-end shipment traceability, data accuracy, and productivity, leveraging source data and context from Portcast embedded into the collaboration tools and automated workflows of Siemens AX4. So the customer implemented AX4, so the digital logistics platform, to centralize and automate premium freight management. As I mentioned, aside from what we just looked at, right, so key features included real-time shipment tracking, automated RFQ and approval workflows, and a flexible UI. Designated super users led the system rollout of the original implementation, ensuring smooth adoption across global region. And this resulted in improved user productivity by 50%, data accuracy by 70%, while reducing premium freight costs by over 10%. And the company gained end-to-end visibility and control over logistics operation, leading to better decision-making and carrier performance tracking. The streamlined communication automation enabled faster, more efficient freight management and stronger carrier collaboration. I think we come to another question now.
Exactly. So it's really exciting to learn more about this customer, and it's especially exciting that we are helping the customer to actually bridge the gap of the missing information with data that is provided in the solution. So to wrap it up and move afterwards to the Q&A session, what is in there for chief supply chain officers, for all the decision makers in the room? So how would you describe what is the major benefit for them when they implement such a solution?
Yeah, so I think the key point is that there are many tools out there and many tools that come into play. We're seeing AI agents in the logistics domain start to get attention. extending the concept of collaboration, can be built to act in and around the workflows we're looking at, right? And both operationally and also in simulations. There's also a number of document processing solutions, which have a clear value proposition in logistics and international freight. The, I think, highlight, though, is that infinite use cases can also mean infinite failure modes, right? So the point I really want to stress is that the potential and measurable success is great as long as the implementations exist with the same software lifecycle development checks and balances and operational excellence guardrails that apply to any other feature and process. And additionally, are implemented with clear objectives that can be empirically evaluated. So in AX4, we have some Copilot type implementations. There's also some connectors related to AI agent implementations. The point is that it's not one size fits all, right? It's extremely specific to the data that is at hand. And when there are problems, when there are issues, they still tend to be foundational. So having the data, access to the right data at the right time, then how you can extend, let's call them human workflows, right? And enable workflows that are not possible with the current resources without these types of tools. Still, it's not magic, and it can't be implemented as something that lives outside of the not just operational but also security. I should stress we haven't talked about the security topic, but in supply chain, when it comes to disruption, given the wide environment of IT tools that are put in place, that is another significant dimension, and it's something that is also quite a large topic of discussion on AI tooling. We lost Nidhi. I hope not.
Okay, maybe she has some problem with the connection. So let's hope that she can turn back to the session soon. Thanks a lot for sharing this insightful discussion with our participants today.